DTN3043115289. So today I'm going to talk about system structure. What is system structure? Defined as an arrangement of computer components that are interconnected and work together to carry out tasks such as receiving input, processing input according to the instructions given, and producing output that code informations from the processing. So this is how we are going to explore the fundamental architecture of a computer system. The image we provide is how the high-level abstractions of how a computer works internally. So it is called the core of any computer system. This is simple to compute, to get information, process it, and deliver a result. To achieve this, every computer system consists of four essential components that work in harmony. So the first one is input device. This is where the journey begins. Input device like the cable or mouse allows us to feed data as instructions into the system. They are the gateway for us to interact with the machine. So the secondly, output devices. After the data is received, we need a way to see or use the result. Output device such as a monitor or printer take the process information and present it in a human readable format. So for example, if we type A on the keyboard, so the output on the monitor, as we can see, the word of A. So the third one, the processor, that was called CPU, often called the brain or central processing unit. The processor is where all the actions happens. It is interprets and executes instructions, performs calculations, and it manages the flow data. So, the fourth one, memory or RAM. Register address memory. The processor needs a temporary workspace to store the data and instructions. It's currently using memory serves these functions, providing quite quick access to information as the processor needs it. So, the fifth one is communications, or we call the buses. The components don't operate in isolation. They communicate using buses, which are pathways for electronic signals. So next was about data bus. This carries the actual data back and forth between the memory, processor, and input or output port. So next, address bus. This is used by the processor to specify the exact locations, the address in memory where it wants to read the data or write the data to. So next, control bus. This bus carries control signals that ensure all operations are synchronized and managed correctly. So about this one, so input or output devices, a device that functions to transfer data between a computer and an external environmental or vice versa, or input or output port. The input or output devices consist of two parts. That was the first one, mechanical components. That was the device itself. Secondly, electronic components. Its devices controlled in the form of controller chip. Operating systems are more concerned with electronic devices than mechanical devices. The devices is a real device controlled by controller chip in the system board or card. So this is an example of input input devices or output devices. For example, input, as we can see, mainly used for everyday uses as a TV or computer. We can see keyboard and mouse. So output devices, as we can see, screen monitor or recorder. So this is the example of input or output port. So this picture is about the Pandora PC uh, 0104 input or output port. So the step we are looking at this very specialized piece of computer hardware known as the Pandora, both from Diary System. This isn't a standard computer what you find in a laptop or desktop. It's belong to a niche standard called PC104, which is designed for industrial and everyday applications. So, key features that we can see in this port, which is the primary purpose of this port is to provide a robust input or output for the panel. It takes the generic data signal from main embedded computer board, which would stack directly on top or below it and makes that accessible rather than the physical connector. So you can see a several important interface highlighted. For example, fast through the BGA connector. This allows for connecting a standard monitor to the system. Then COM ports. These are the industrial series port essential for connecting to legacy or specialized industrial equipment. The third one is dual input power checks. This flexible power option is critical in harsh environmental like vehicles where power source might vary or redundancy is needed. Other standard interface like Internet or networking, USB for modern peripherals, and older PS2 ports are also present. So, usually these ports used in military systems, industrial automations and control, also robotics and vehicle computing. So the next topic is processor. The processor is the heart of the computer which functions to control computer operations and carry out data is processing. The processor computer performs logical operations and manage data flow by reading instructions from memory and executing them. Processor executions is driven by the clock. The clock is used to generate pulses to the processor. On each new clock pulse, the processor performs work. Processor is usually called CPU Central Processing Unit. Third, so we going to the next part is reading mechanism. To read data from the memory locations, the CPU sends the desired memory address or whereby we call as the address bus, then sends a memory lane signal on the control bus. The memory signal instructs the memory devices to output data locations to the data bus so that it can be read by the CPU. So next instructions. Order that must be executed. Processing instruction is carried out in two stages. One fetching instructions and the second one execute the instructions. So how the processor performs? The processor performs work in the following steps. The first one is retrieve code instructions binary from the main memory. Second, decoding the instructions into action symbols. And the last one, carry out actions. The processor consists of three main components. The first one is CU, control unit, functions to control the operations carried out by the computer system. Second, ALU, arithmetic logic unit, functions to perform arithmetic and logic operations. Third, register, help carry out processing operations. Register functions as very fast memory, usually as a place for the occurrence of the operations to be performed. So the lastly is interrupt. Signals from a external equipment, requests from the programs or error message to perform a specific task. If an interrupt occurs, the ongoing process is stopped. First, to run the interrupt routine. Types of interrupts. The first one is software interrupt caused by software system call. Second, hardware interrupt caused by actions of the hardware. Example, pressing a keyboard button or mouse button. Type of hardware interrupt is the first one is most able interrupt. interaction from outside. So the second one, non-max error, interrupt, for example, memory, input or output property errors, and process error. So that's all for me that I know about system structure. Bye. Thank you. Welcome. Thank you for watching.